This is an introductory lecture on seepage analysis. So before we start into seepage analysis, I would like to discuss the three heads which we generally study in fluid mechanics, and those three heads are pressure head, second one is velocity head, and the third one is datum head. So from FM itself we know that head is nothing but energy represented in the form of height of a fluid column. So head is nothing but energy which is represented in the form of height of fluid column. From Bernoulli's equation we have pressure head as P by rho g, velocity head as V square by rho g, while datum head as Z. In seepage, velocity head is negligible. Hence, this parameter is taken as 0 or neglected, since the speed with which the water flows through the soil or in seepage, its value will be around 10 to the power minus 4 meter per second, or maybe even less. So hence we don't take this thing into account. Hence velocity head is ignored. Hence total head in seepage remains pressure head plus datum head. Now this term, this combination of pressure head and datum head is also known as, from fluid mechanics, piezometric head. We can also write piezometric head as P by rho g plus Z. Hence in case of seepage in soil, total head is piezometric head. Now comes the next term, that is seepage force. Now what is seepage force? Seepage force in the soil is due to the viscous drag exerted by the water on soil solids. Force in the soil due to viscous drag exerted by water on soil solids. Again, seepage force always acts in the direction of flow. Now is a figure to make you understand seepage flow and its parameters. Let me draw soil with some different color. Suppose this is our sample of soil within a tube. This is the level of downstream water and this is upstream water, let us say, with higher head or higher energy. Since water will flow from high energy, higher head to lower head, let us consider this as downstream head. Let this be the length of the soil sample or porous material. Now the flow is going to be taking place from upstream to the downstream. Let the difference between the level surfaces of the upstream and downstream water be h. Then seepage pressure at inlet of soil will be H rho W. This is also from FM, where we used to say that below the water body surface any point down the water table, the pressure at that point, according to Pascal's law, if I am sure, P was given as rho GH, where H was the height from the water surface, or P was written as, since rho G can be written as gamma H. Similarly, the seepage pressure at inlet of soil will be H rho W, which we can see from the diagram itself. Now, the seepage pressure at outlet will be 0. Of course, the seepage pressure at the outlet has to be 0, since there won't be any H at the outlet. Now, seepage pressure in between is said to be as H dash gamma W. The next term is, after seepage force, we have is seepage pressure, written as PS. PS is written as H rho W. Now multiplying L in numerator and denominator, H by L is nothing but gradient I gamma W L. This is what is seepage pressure. Now what about seepage force? Seepage force Fs is written as force is pressure into area. We'll write I gamma WL into area. Area into length will be volume. So this equation becomes I gamma W into volume. Now force per unit volume, that is seepage force per unit volume, is considered as small fs. It is written as I gamma W. Where fs is what? Seepage force per unit volume. In the next lecture, we will see effect of seepage flow on effective stress. So we have discussed three heads which we generally considered with the fluid flow. Those are pressure head, velocity head and datum head. What is head? Head is the energy represented in the form of height of a fluid column. It can be water, it can be any other liquid. Pressure head is represented by P by rho g. All of this is actually from FM, Bernoulli's equation. And velocity head is V square by rho g, while datum head is Z. So in seepage, the flow of water is too slow that velocity head is disregarded. It is considered as negligible. So the total head available in seepage analysis is pressure head and datum head, which is also known as piezometric head. Now the seepage force is the force due to viscous drag exerted by the water on soil solids. Seepage force always acts in the direction of flow. And here are the formulas for seepage pressure, which is I gamma WL, and seepage force per unit volume is I gamma W. Thank you.